You know, in math, there are some rules you just don't question. They're like the laws of physics. But what if someone came along and said they broke one? A really big one that's been around for 200 years. Well, that's what we're looking at today. A paper that claims to solve something everyone thought was impossible.
Yeah, I'm talking about an equation that for 2 whole centuries wasn't just considered hard, it was proven, mathematically proven, to be impossible to solve with a general formula. So the big question is, what if that proof was wrong? What if that limit never actually existed?
Okay, so to get what's going on, we got to go back to basics. The story really kicks off with one of the oldest quests in math, solving for x in a polynomial equation. You remember those from school, right? With all the different powers of x? For a long time, mathematicians were making some really solid progress. I mean, for thousands of years, they were just knocking them down. Way back in antiquity, they figured out quadratic equations, that's degree 2. Fast forward to the 16th century, and boom, they nailed down formulas for cubic and quartic equations, so degrees 3 and 4. It really felt like we were on a roll, you know? Like nothing could stop us. And then we got to degree 5. And everything just stopped. The whole field just hit a brick wall, hard. And this wasn't a case of mathematicians just not being smart enough. Nope, a brilliant young guy from Norway came along and proved that they were stuck for a very good reason. He basically said, guys, you can stop trying. Because it wasn't just hard, he claimed it was literally impossible. And that became known as Abel's impossibility theorem. What it proved, in essence, is that you can't come up with a single general formula, using just the usual stuff like addition, subtraction, square roots, cube roots, that will solve any polynomial equation once you get to degree 5 or higher. It just can't be done. And this wasn't just some passing idea. It became a fundamental law of mathematics. And this is the part that gets me. This wasn't some dusty, forgotten rule in an old textbook. No way. It was a cornerstone idea that completely shaped modern algebra, analysis, even how we think about what's possible in math. It was like a giant, permanently locked door.
So for almost 200 years, that was it. That was the truth. The door is locked, case closed. Until now. A new paper has just come out with a claim so bold, so audacious, that it's basically saying, hey everyone, what if that door was never actually locked at all?
This paper, from Murad Sultan Ezweidi, isn't just pushing the envelope a little bit. It's claiming to have done the exact thing Abel's theorem said was impossible. It claims to have found an exact algebraic solution for a polynomial way higher than degree 4. We're talking about a 10th degree polynomial here.
I mean, the ambition here is just wow. The paper literally calls it a revolutionary method that works beyond Abel's impossibility theorem. And let's be clear, this isn't about getting a close enough answer with a computer. No, the claim is that they found the exact formula, the real deal.
So, the big question is how? How on earth does this paper claim to pull off the impossible? Now don't worry, we're not going to try to solve the math ourselves. I wouldn't do that to you. But let's peek under the hood at the method they're proposing. All right, it's called the Ezweidi-Murad Sultan theorem, or EMST for short. The basic idea is that it's a framework built on 3 key techniques. First, it uses something called symbolic recursion, which is just a fancy way of saying it builds the solution one step at a time. Then, it transforms the equation to make it, well, a little less terrifying. And finally, it hunts for hidden patterns within the numbers of the equation. And this isn't just theory. To show it works, the author takes this EMST method and applies it to a real, gnarly 10th degree polynomial. The whole point is to show, look, I can take this method, run this equation through it, and get a concrete answer at the end.
And when you actually look at the paper, this is what you see. It's page after page of dense, step-by-step calculations. For each step, which they call K, a whole new set of numbers gets calculated. It really is like looking at the blueprints for a super complex machine, where every single gear has to turn perfectly to make the next one move.
And this just keeps going, step after step. With each iteration, the equation gets transformed a little bit more. And again, you and I don't need to follow every single plus and minus here. The takeaway is just to see that there is a clear, structured process at work. It's not magic, it's a very deliberate procedure designed to get to a final answer.
Okay, so after all that work, all those pages of calculations and transformations, what's at the end of the rainbow? What's the final answer that this whole method spits out?
And this is where it gets really interesting. Because what we have here is a head-to-head showdown. In one corner, you've got Abel's theorem, a 200-year-old heavyweight champion of algebra. And in the other corner, you have this paper claiming it's produced the exact kind of formula that the champion said could never, ever exist.
And there it is. That's the supposed solution, the explicit algebraic formula. The paper isn't saying X is about this much. It's saying X is exactly this. This formula right here is the mic drop. It's the absolute core of this revolutionary claim.
So, what now? Well, the ball is now in the court of the global math community. They're the ones who have to take this paper, pull it apart, test it, and see if it holds up. But honestly, whether it's right or wrong, the fact that someone is even challenging a law this fundamental, that in itself is a huge deal.
So what's the big takeaway here? I think it's that even a mathematical law that's been on the books for 200 years isn't necessarily untouchable. This new EMST method claims to have the key to that door everyone thought was permanently locked. Now, we have to stress this. The claim still needs to be proven and checked by experts. But it's just an incredible reminder that in the world of science and math, impossible is sometimes just another word for we haven't figured it out yet.
And that really leaves us with a pretty wild thought, doesn't it? If a 200-year-old law of math can be put into question, what else do we think is impossible that might not be? It really makes you wonder what other locked doors are just waiting for the right key.